Good day. I'm Martin Gagel with Market Radius Research. It's Wednesday, May the 10th, and we've got CEO Olivier Newton and COO Nick Newton of BTQ Technologies. BTQ has developed and is developing security solutions for post-quantum environments. I'm always very excited to have hard science and hard tech stories we can dig into. It's also cool when the presenting company are able to identify their key technology people with their H-index or their impact that their academic research has in the field. So this is pretty interesting stuff we're dealing with. But please remember, this is neither recommendation nor investment advice. We're here to learn about the company. Olivier and Nick, thank you very much for joining us. And please walk us through your deck and tell us what you guys are up to.
Thanks, Martin. And thanks for having us. I think really our kind of venturing into investing in quantum computing started around 9 years ago or so, when we started funding research specifically around quantum encryption protocols and their effect, being both from Vancouver, Canada. We had some exposure to the great companies around the Vancouver area like D-Wave Systems that are operating and building large-scale quantum computers, and we wanted to position ourselves with some strategic assets and intellectual property development in the specifically looking at how the quantum computing landscape is going to evolve, that there will be a near-term future where quantum computers exist, and the need for quantum encryption to be able to mitigate the risks associated with these coming online. So that's really where things started. I would say about 3 years ago, when my brother Nick was helping me with some of my projects, I said, let's look at figuring out the commercialization angle of our intellectual property that was developed over a number of years. At the time, I was running a company I founded called Hive Blockchain, and so was specifically interested and saw a potential risk factor essentially for quantum computers to break existing blockchain cryptography. You see, a lot of hostility of governments around the world, China, the US, towards cryptocurrencies and blockchain infrastructure. So thought it would be, potentially an interesting use case to explore our quantum encryption intellectual property applied towards these blockchain networks, which has turned into a multi-trillion-dollar asset class. And so that's really where we decided to gear our initial focus. And by focusing on essentially bringing in post-quantum encryption infrastructure to blockchain environments, we were able to, I wouldn't say stumble upon, but widen our scope of intellectual property to the fast moving and acceleration of where traditional technology protocols lie and how that's affected by quantum encryption. So I'll let Nick walk through the deck, and we can go from there.
All right, gentlemen, I just to make sure everyone's up to speed on quantum computers and cryptography and encryption. Quantum computers process entirely a different way than, call it, traditional silicon binary computers. And the concern is that these new quantum computers they'll be able to hack current encryption systems very rapidly, and how we payment process and all that, what kind of the pipeline of the internet. And so and there are quantum computers right now, they're growing in scale and size and speed, and the world's trying to figure out how to encrypt all this communications we're used to right now, when the bad guys or good guys or whoever it is have quantum computers that could readily hack the system. And that's what you guys are building protection against. Did I get that kind of right?
That's right.
All right.
And
thank you. I just wanted to make sure everyone's sort of on the base level field and that before you go ahead here. Thank you.
Sure. So I'll just jump right into the presentation. So BTQ, we're over 30 employees now. We have a presence in Vancouver, Taipei, Tokyo, Europe, Australia, and we've assembled a leading team of post-quantum researchers to develop these new solutions for blockchain and other industries. And what brought us over to Taipei and to Asia was there's a huge amount of post-quantum research ongoing there. And we're looking at a number of exciting use cases from distributed ledgers, blockchain, to other near-term applications of quantum computing technologies. So we see ourselves as the first listed company focused on near-term quantum use cases. And we have a number of world-class partners that we're developing intellectual property with. So eTree, which is the leading hardware institute globally, as well as Macquarie University down in Sydney, Australia. So these are long-term relationships that we've now been working with these partners for several years, both on software and hardware. There's implications for both when it comes to implementing these new encryption algorithms that are quantum secure. And the team, so Olivier, the CEO, I'm running as a COO, and Chenmo Chen, who's our co-founder and chief cryptographer. So I met Chenmo through our mutual interest in quantum security, and Chenmo and other academics in Taiwan were very involved in the US government standards process to come up with new quantum safe encryption algorithms. So we thought it was a great way to, great place to start a branch office and to hire other researchers with this very specific expertise. I think globally there's a very small talent pool for post-quantum cryptography expertise. So us being strategically positioned with a branch office in Taipei gives us a unique advantage. And Ming and Pochan and other team members are all in this community of academics. They've known each other for decades. So it's a very tight group. And we have Peter, who's our chief legal officer, also based in Taipei. Our board of directors, so Johan, Kevin, Michael, just a great support team. So Kevin is vice president of Broadridge Financial, Johan, co-founder of Norteed Capital, and Michael, who's been helping out. And we have a huge focus on semiconductor technology at BTQ. So we're really excited to have Wei Qi as our head of hardware engineering. I'm formerly a professor at Fengsha University in Taiwan. And we do have an office in Tokyo. So Kari Tanaka is leading that. And then other members from our team, Chris, Matt, Brian, and our advisor, Gavin Brennan, who's the director of quantum engineering at Macquarie University in Sydney, Australia. And as Olivier mentioned, we've started investing in quantum security intellectual property about 9 years ago. And over that same time period, there was a standards process in the United States that initiated in 2015. And this was an open contest, open for submission. So academics and companies globally submitted quantum secure algorithms to this standards contest. And over the past 8 years, the whole community has been looking to identify algorithms that are safe, secure, have fast performance. And as of last July, NIST, which is the US government standards body under the Department of Commerce in Washington, DC, announced a handful of algorithms that have been selected. and standardized. And now industry is essentially adopting these across the board. And there's a lot of optimizations that need to be made because these new standards have different mathematical foundations than what we're using currently. And I think just to demonstrate how urgent this is, President Joe Biden has been putting out executive orders mandating quantum encryption across the US government. And below here, these are the algorithms that were standardized, so both for public key encryption and digital signatures. So this touches essentially everything on the internet today.
And are those standards, are those sort of quantum computer proof, so to speak?
That's right. So those have no known quantum attack vectors.
Okay.
So this has been essentially over the decades, there's been assumptions in the cryptographic community of which type of math problems are secure against faster computers like quantum computers and which are not. So the algorithms that were standardized last July are known as quantum safe algorithms. And that's why there's now a huge global transition to these new algorithms across essentially every industry.
How, like the internet industry or infrastructure, like the Googles, the network carriers and so forth, how far are they along in sort of incorporating these encryption methods into my browser and all those sorts of things?
Sure. So most of the major tech companies have been involved in this standards process. So they've submitted their own algorithms as part of this. And certainly you're seeing huge efforts from these tech companies to implement post-quantum within internet infrastructure, CDNs, and so forth. But it takes a lot of time. So historically, these types of transitions take 10 plus years, just given the amount of work that needs to be done and all the systems that need to be updated in both software and embedded systems, hardware. So it's a huge undertaking that doesn't happen overnight.
Do you have a sense whether the current quantum computer infrastructure out there at the D-Waves and Google and the NSA probably has some big ones buried in some bunkers somewhere, are those able to readily crack the current sort of top standard encryption mechanisms, or are we still a few years away from them being crackable?
So I think why there's so much urgency to transition to quantum security today is because a lot of this data, even encrypted data, could just be harvested. And if the attacker has a long enough time horizon, 5-10 years, they could just be harvesting data and then decrypting it when they have a universal quantum computer. So for companies, governments with long-term data security requirements, they need to be encrypting information today with post-quantum security. And yeah, there has been numerous advancements in the quantum computing sector globally. Governments, of course, are involved. Not all of the research is published. So some of the leading quantum startups like PsiQuantum don't necessarily publish what they're doing. So we're not subject to all of the innovation and advancements that have been taking place. But Olivier, do you want to add anything?
Yeah, I spent several years living in China and witnessed firsthand the billions of dollars that the government is spending on their strategic quantum research and development initiatives, and obviously their disclosed budget versus their actual budget. It's at the end of the day it's a military defense related applications. So the advancements of quantum computing differs from what is in the public hands to what is also being created behind the scenes. So the sense of urgency is very real, and as we've seen kind of in the last year with technologies such as artificial intelligence, out of nowhere, there's huge growth catalysts. So there's, it could be a matter of years or potentially tomorrow where there's a significant advancement in the mathematical science behind the factorization of qubits, which could jeopardize information security standards today.
All right.
Yeah, I think people tend to refer to this as Y2Q, so similar to Y2K. We don't know the date when quantum computers are going to emerge, but it's that type of transition, and it's that type of core infrastructure to the global communications networks, and that's what's at stake here.
All right.
And I think just to touch on some of the industries that are focused on this transition, and there's been a lot of publications recently from think tanks in the US advocating the transition to quantum secure standards. And one of the leading publications that we recommend is from Michael Vermeer from RAND Corporation, who's been helping the government with this strategy. And we're also seeing a lot of public figures like Ren Zhengfei, founder of Huawei, just warned about the threat of quantum computing as it relates to core infrastructure like blockchain. And this is just a side-by-side comparison when it comes to something like factoring on a classical computer versus a quantum computer. So quantum computers are exponentially faster. So problems that could take thousands of years on a conventional computer could literally take seconds on a quantum computer, hence the threat and the vulnerability to public key cryptography. And this takes us to BTQ and some of the solutions that we're rolling out this year. So we have a number of offerings around quantum security and software and in semiconductors, as well as other primitives like zero-knowledge cryptography. So we have the first suite of products that target post-quantum zero-knowledge software and hardware as well. And there's a lot of use now for zero-knowledge cryptography across several industries, including blockchain. So we'll get into these in a bit more detail. And our core R&D effort, one of them has been PQ Scale. So this is a solution that is built on top of these NIST US government standards that enables any blockchain to be post-quantum compliant. So it's a simple software API solution that essentially takes advantage of our hardware acceleration as well. So you can simply call PQ Scale on a usage basis, and we return post-quantum signatures for use in your blockchain application. And a QSIM, so every IoT device, every connected device is going to need to support post-quantum standards. And right now there's no IP cores to support post-quantum standards. So we're developing with our partner at eTree what's known as QSIM. So it's IP that can enable any company that's building hardware IoT devices to support post-quantum standards and license this technology from BTQ on a usage royalty basis. And Keylung and Kenting are our product offerings focused on zero-knowledge cryptography. So we're seeing a lot of applications for zero-knowledge, especially in blockchain. This improves latency and performance on blockchain networks. This is why Ethereum and other blockchains are moving to ZK first infrastructure. So Keylung makes it easy to write applications in zero-knowledge cryptography. And this ZK is very computationally intensive. So Kenting helps accelerate it and optimize the performance of the ZK infrastructure.
Are you able to just give a dummy's version of what you mean by zero knowledge encryption or algorithms, and that, just so people can get a sense of what you mean by that?
Sure. So zero knowledge cryptography, just as a simple use case. So let's say you want to demonstrate that you're an accredited investor, but you don't want to show your underlying bank information, underlying network to an outside party. You can use zero knowledge cryptography to basically prove that you are an accredited investor without revealing the underlying information. So that's kind of one of the use cases for zero knowledge. So essentially proving information, but without revealing it.
Okay, so you know you're answering the question honestly, but you don't know how many assets you have that are over the required limit.
It improves privacy because there's a lot of use cases where you don't want to reveal certain information.
Yeah.
But you do want to essentially gain access or participate in a community. So that's what zero knowledge enables one to do.
All right.
And so we're very excited to be working with ITRI. This is the Government Research Institute in Taiwan. They're well known for incubating Taiwan Semiconductor, TSMC, and a host of other large companies in Taiwan. So we're developing QSIM in tandem with them. So there's a lot of potential avenues for this intellectual property. One would be automotive electronics. So any, I think, keep in mind, the large car companies. Of course, when you're shipping a car next year, that needs to be secure for however many number of years. So that's why a lot of these industries are thinking about implementing post-quantum security directly into the hardware. And we're excited to be working with Stellar. So Stellar is one of the largest public blockchains, multi-billion-dollar market cap company. And they are working with us on PQ Scale, which is our quantum security offering. So what's really exciting is that Stellar is focused on central bank digital currencies and other applications for use of their blockchain. So we're making sure it's post-quantum compliant with our solution. But Olivia, do you want to add anything to?
Yeah, I think as we're seeing, and as Nick alluded to in the in specific use cases like the automotive sector, where there's specific sectors who cannot take the risk or affordance in terms of the longevity or potential risk of quantum computing becoming mainstream. You're seeing pragmatic companies and thinkers adopting post-quantum cryptographic primitives earlier than later. So one of the other interesting applications and areas that we've been experimenting on is the advent of CBDCs, or central bank digital currencies. So there's a global rollout led primarily by the Bank of International Settlements here in Switzerland about research and development for what does currency look like in the modern age, and the blockchain, how the specific blockchain standardization protocols to support that. And obviously post-quantum cryptography is playing a huge part in that. So as governments and nation states roll out their CBDCs, they want to make sure that their underlying blockchains that they roll that out on are secure cryptographically for generations. So we're seeing some very interesting near-term use cases for specifically post-quantum encryption when it relates to blockchain in that regard.
And I presume not just Stellar, but it's across pretty much any kind of blockchain could utilize.
Correct. Well, yeah, you're seeing, basically digital store of value for a new generation occur within, Bitcoin and Ethereum and other top digital public blockchains, right? I think you've seen it as of recently, with the US banking collapses, spikes in BTC appreciation as a digital value store. But for that narrative to uphold the underlying cryptography of Bitcoin, Ethereum, and the likes needs to be able to withstand decades of advancements in cryptography. So that's been a core area of focus. And I think, essentially most of our intellectual property that was devised in terms of figuring out how to compress and miniaturize post-quantum encryption standards to fit within high transaction throughput environments, such as blockchains, has led to a lot of different breakthroughs for our intellectual property, applying those miniaturization techniques to other sectors.
All right.
And our partnership with Macquarie University is going extremely well. We're thrilled to be working with Professor Gavin Brennan, who's the Director of Quantum Engineering there, also the Executive Board Member of Sydney Quantum Academy, a collaboration among all the top 4 universities in Sydney. And we're doing a lot of outreach in Australia. So I was just down there recently to participate in the Quantum Australia conference. So Gavin shared a panel there along with Lily Chen, who's the CEO of NIST. And Gavin has been working on near-term applications of quantum information and quantum computation. So we think there's some really exciting opportunities around leveraging near-term quantum devices. So quantum devices that are available commercially today from the various quantum computing companies, and implementing quantum consensus protocols. So looking at a blockchain applications and implementing quantum mining techniques, which could have vastly improved energy savings and so forth, and kind of come up with the first commercially viable use case of near-term quantum computers. And this is just one of the areas that we're looking at with Gavin, and we have a team of researchers that work under Gavin at our office in Sydney, which is at the Quantum Terminal, which is a government initiative. So we're excited to be in that community.
Yeah, I think, and just to go back on that slide, Nick, I think, we've been extremely grateful to work and retain some of the top minds in both quantum and cryptography, which has led us to a lot of groundbreaking research. And specifically to touch on Nick's point, really using existing quantum primitives for near-term and real-world use cases. So you see this, you see this continual attack, I would say, on Bitcoin's proof of work mining algorithm for its energy consumption. In the last month or two, you've had the US government hike its tax on Bitcoin miners 30%. In Sweden, you've seen a 6,000% tax on data center and miner operators. So that's not going away anytime soon. And some of our work that we'll be excited to announce in short order has been around using quantum design within blockchain and consensus networks to optimize the energy efficiency of that underlying proof of work operation.
All right.
So our company milestones. So what BTQ was formalized in March 2021, and we're now, as of a couple of months ago, a public company with a NEO listing, and recently, this past week, an OTCQS listing. And we've been doing a lot of outreach recently at various conferences. I'll single one out. So in December, we co-organized a post-quantum cryptography workshop with NIST, where Chenmo and Po Chan, our CTO and chief cryptographer, gave presentations on our research, and also had speakers from companies like Samsung and NXP Semiconductors. And we also presented at the Foxconn Next Forum on quantum communication technology and applications in December as well. And we've done a number of conferences and presentations in Japan as well recently with Kaori and Chris, our head of partnerships, leading that. And we've had a lot of coverage recently. Bloomberg, CoinDesk, Semaphore, just on our partnerships, and the NIST standards process has really received a lot of attention since the announcement last July. So there seems to be a lot of organic coverage on this sector and space, and I think we'll see that continue. And so we are inventing a lot of these primitives for zero knowledge, post-quantum zero knowledge, and blockchain. So we're uniquely positioned as a first mover, and now in the public markets, we can take advantage of that. And also expand our existing partnerships and relationships with the likes of Macquarie University and ITRI, the leading hardware institute globally. So we'll be looking to build on those partnerships and keep kind of have a ramp up all of our product offerings, which are coming online within this year. So I think that's high level on the presentation, and perhaps just this slide here. There's been a lot of research on Bitcoin and its quantum attack vectors, and this is only going to keep. I think there's so much discussion now in the blockchain community about post-quantum. We've seen roadmaps announced by Ethereum Foundation and other large public blockchains. So I think we're going to see every chain need a post-quantum strategy. And BTQ right now has the only NIST approved technology for blockchain. So we see a large opportunity there to be the de facto provider of chains that value long-term store value and post-quantum security.
Okay. So your basic business model, a revenue model here is you're developing technologies and then you're going to be licensing it out for other people or other organizations to use, and you'll get a licensing fee off of that. Is that correct?
Sure. So our hardware, semiconductor technology, yes, we will be licensing for our post-quantum compliant blockchain solution, PQ Scale. It's a cloud offering, so it's usage-based. It's like a payment processor. We're taking fees off of transaction based on volume. So we're going to existing blockchains that have volume and partnering with them on a usage basis.
So there'll be like an API, they'll go out, say, hey, process this for me. You come back, they put it on the chain, and then you clip a few points for that transaction.
That's right.
All right. And you're also in the, I forget, sorry, the different products, the names for them, but also going into like IoT devices or devices that would go into semiconductors or hardware cells. You're not designing your own chips, your own silicon. You'd be licensing technology to existing silicon companies, and then you would get a couple of bucks or whatever per hardware device that gets shipped with your technology on it. More traditional technology licensing arrangement.
Right. And I think we have an amazing partner in ITRI, which has a global network and is the leading research institute on hardware and IP licensing. So we're certainly going to take advantage and look at other partnerships we can do in Taiwan, where most of the major hardware companies are based.
All right. And so, and you said you're launching these it sounds like, well, or you said you're launching them this year, so we're very close to completion, so to speak. And then if you're launching them, does that mean, I believe right now you're not at revenues, but then is 2023 a year of revenues, or does it take a little bit longer for that to kick in?
Yeah, so the Stellar deal that I mentioned, so PQ Scale, Kenting, Keylung, all of those products are being used by early customers and a select group of beta customers. And then we expect QSIM to ramp up in Q4 this year. Yes, there is near-term revenue opportunities for us, and we're already working with customers like Stellar. Yeah, absolutely.
All right. So what kind of catalysts or news flow should investors be expecting, let's say, through the remainder of the year? What kind of things to look out for?
Yeah, I think we'll be continuing to update new product releases, partnerships with market fit for the technology, as large corporations, governments, and research institutes. We will continue to provide information on all those partnerships. So I think that's something to look out for, and we're I would say fairly dormant on the news front, but we are working around the clock on the commercialization of our culmination of research over the last 9 years.
All right, so we're going to get a bunch of hopefully commercialization news coming out through the remainder of the years, which presumably some associated with revenues or near-term revenues associated with that.
Correct.
All right. Okay. We covered a lot of ground here. We see that the product launches soon, commercialization soon, ongoing technology development. Anything else you want to highlight here?
I would highlight the NIST standards process. So they're very clear and transparent about when companies and governments have to transition to these new standards. So, it's already kicked in, but the final specs for these standards are finished in Q1 2024. So if you're a credible organization, you need to follow NIST standards. So there's a lot of documentation that's public information on this. And that's how we see commercialization. There's going to be a huge ramp up in the next year, as everyone needs to support these standards.
So the final standard, like they've got the core framework of it, but the final sort of lockdown standards are coming out next Q1 2024. And then once that's locked down, then people can start really rolling out final products based on those standards.
Right.
Okay, and that's, I guess, so there's going to be limited release until everything's really locked down, but then call it the floodgates kind of open next year.
Yeah, and for various use cases, just like the timeframes for hardware development are much longer than software. So
yeah,
we're looking at 18-24 months to develop hardware. So that's why there's so much urgency this year, right? Because it's going to take longer to bring that to market.
Yeah.
Yeah, no, there's already been large companies deploying post-quantum cryptography this year. Cloudflare, Google, Amazon, IBM are all actively deploying this.
And using the NIST standards?
That's right.
Okay. And then they just, if there's some they need to maybe tweak it a bit, but they're basically on the right path.
Yeah, so there's a lot of use cases that have to be optimized.
Okay.
like let's say blockchain, NIST is not building post-quantum standards for blockchain. So BTQ is really a dedicated effort to come up with post-quantum blockchain standards.
All right. Just, it's always good to end the presentation. Do you have a just your cap table? What your balance sheet looks like right now? Just go over the stock stuff.
Sure. So on the slide, so we listed at around 40 cents Canadian on the NEO exchange. We're now trading in Germany and in the US as well. And for use of funds, we're primarily doing software and hardware development, but our cost structure is, I think, quite attractive, not very capital intensive.
All right. How much money did you raise? Was it an IPO where you raised money on it, or you just sort of more of a direct listing kind of model?
No, we did a reverse takeover where we raised just over 7 million, and the company to date has raised 14 million today. So we have, I would say, a multi-year runway as it is, and expecting commercialization contracts to start coming in, and there's also billions of dollars in government research grants and non-dilutive forms of capital that we are actively have a team pursuing, and it's helpful to also be in multiple jurisdictions for those efforts. So there's large Canadian, Taiwanese, Australian, Japanese, and EU related quantum development grants.
All right, gentlemen, thank you very much. You covered a lot of ground. It's real cutting edge things you're highlighting where the world is going, and I think Olivier, one day 6 months ago, AI and Chat GPT sort of changed the world, and then when is that going to happen with quantum? And people have to watch out for the next major steps as technology progresses and how impactful that can be, how rapidly. So thank you very much. Really appreciate the rundown on BTQ and watching how things progress here. Thank you very much.
Thanks a lot, Martin.
Thank you. Cheers.
Cheers.
Thank you.